In the previous class, we have discussed about crystal systems and unit cell, right? So the unit cell is nothing but what? The repetition of the regular arrangement of the unit in a crystal plane or crystal lattice. We call it as what here? Unit cell. Unit cell consists of how many types? Four types. What are those? That is simple unit cell, body centered unit cell, face centered unit cell, and face centered unit cell. And coming to here, simple unit cell is nothing but what? It consists of 8 corners. We call it a simple unit cell. If it is containing 8 corners plus 1 atom in the middle, that one we call it as body centered. Face centered is nothing but what here? 8 corners plus 6 faces, we call it as face centered. And face centered is nothing but 2 opposite end faces. And here we are going to have here 8 corners, that one we call it as end face centered unit cell. Today let us discuss about number of atoms per unit cell in a cubic lattice. So in a cubic lattice, how many atoms consist of per unit cell is nothing but here general example I will say here. For example, I am having 10 rupees and I have taken 10%. So the 10 rupees are distributed equally to the 10%. So then for each person how many rupees it will get? 1 rupee, right? The same thing we are going to calculate in the unit cells also. So let us see here, generally simple cubic cell we are saying. So how many atoms here? 1 atom per unit cell of simple cubic cell. So body centered means what? 2 atoms per unit cell of the BCC, 4 atoms per unit cell of the FCC, 2 atoms per unit cell of the N centered. Okay, so let us see this all how we got 1 atom, 2 atom, 4 atoms, 2 atoms in the diagram wise. So see here, let us take here simple unit cell. So simple unit cell in a simple cubic, so what we have spoken, we are having total 8 corners, right? That one we call it as simple unit cell. And if you have been seen the starting, simple cubic cell is having 1 atom per unit cell. So means what here, how we got 1 here? Number of atoms per unit cell. How many atoms we are having totally? 8. Per means what here? 1 by 8. Okay. So how many corners we are having here? 8. Per is nothing but what? For each atom we are going to get 1 by 8. For one atom we are going to get 1 by 8. Like that, how many atoms we are having? Total 8 atoms at the corner. So that's why I have written here 8 into 1 by 8. So this 8 will get cancelled. Then you are having 1. So then what we can say here, the number of atoms per unit cell, how many we are having? 1. I think you have understood. So once again I am saying, see here. So here the simple unit cell consists of 8 atoms at the corners, right? So 8 atoms at the corners it contains. So now, so each atom is having 1 by 8. Okay, like that, how many atoms we are having? Total 8. So if you write here 8 into 1 by 8, when you get cancelled, we are getting here 1. So this is nothing but, if you are getting 1, it is a simple unit cell. Let us see next one. We have taken here example. So here in this, if you have been observed here, so see here, this part consists of 1 by 8, this part consists of 1 by 8, this part 1 by 8. Like this, each part we are taking one part in that. So means what? Per no. So that's why we are getting 8 into 1 by 8 is equals to 1. So this is the diagram for the simple unit cell. So let us see here next one. Example we have taken here is, the example is here what? Polonium. For this polonium we are getting only simple unit cell. Why? Because here the atoms are occupying where? Only 8 corners. So we are getting here per each atom 8 into 1 by 8, we are getting only 1. That's why we say that it is the example of the polonium. So now let us see body centered unit cell. The body centered unit cell consists of what here? 8 corners. Here 8 corners we are having, right? And 1 atom in the middle. So now what we can say, this each 8 corners consist of what? 1 by 8. Per atom consists of, 1 atom consists of 1 by 8 into total how many atoms we are having? 8 atoms. Then in the middle, what we have? One atom is there, no? So this atom consists of only 1 into 1 atom. So then what we get? 8 will get cancelled. 1 plus 1 we are going to get 2. So body centered cubic lattice, how many atoms we are getting? Only 2 atoms per unit cell. Per unit cell, how many atoms it is having? 2. So means what here? 8 into 1 by 8 plus 1. So totally 1 plus 1 we are getting what here? 2 is the for body centered unit cell. So now let us see how it is going to happen. So see here, in this one consists of 1 by 8, and this one consists of 1 by 8, this one consists of 1 by 8, this one 1 by 8, 1 by 8, 1 2 3 4 5 6, 1 by 8, 7, 1 by 8, and here back side 1 by 8. Total 8 we are having, right? So and in the middle what happens? This one is touching only to the all atoms, means what here? Only one we are having. In the middle we are having only one atom. So that's why what we are getting? Number of atoms per unit cell is equals to 8 into 1 by 8 plus 1 is equals to how much we are getting? Totally 2 is the number of atoms per unit cell. If you have been seen the example for this, so what is the example we can take here? The example is here CSCl and CSBr. CSCl is nothing but what here? Cesium chloride and cesium bromide. Okay, so this is a structure of the cesium. So the cesium chloride, the middle one, okay, so cesium chloride, so these are all chloride atoms we can say, and in between we are having cesium. In the same way you can take bromide also. So the bromide is consisting. So totally how many atoms per unit cell we are having? Totally 2 atoms per unit cell we are going to have. That is nothing but body centered cubic lattice. Next one, if you have been observed, face centered. So this face centered here, how many faces we are having? 6 faces. So how many corners we are having? Total see here 8 corners. So means what? Each corner consists of, each atom consists of what here? 8 into 1 by 8, okay, and plus 6 faces we are having, no? 6 into, each face consists of 1 by 2. See here, observe clearly. Here what happens? Each atom consists of 1 by 8, and here each face consists of 1 by 2. Then if you get cancel 8, you are getting 1 plus 2 1s are 2 3s are, then 3. So then you are getting here what here? 4. So how many atoms present per unit cell we are having? Totally 4 we are going to have. Why? Because here we are having 6 faces. Okay, so we are having how many faces here? Totally 6 faces, and here we are having 6 faces. So this 6 faces consist of 6 atoms, no? So per each atom we are having how much? 1 by 2. Okay, if you take corners, how many corners we are having? 8. So that's why it consists of, each atom consists of 1 by 8. So when you cancel this all, we are going to get the how many face unit cell? 4 is the unit cell. So let us take example here. The example is NaCl, NaF, KBr, MgO. NaCl means sodium chloride, sodium fluoride, potassium bromide, magnesium oxide. So these are the examples we are going to take for the face centered cubic lattices. See here, this one 1 2 3 4 5 6. Okay, so total 6, and back side 7. Here back side we are having 8. Total 8 corners we are having. These are all the faces. This one 3 faces, this one 3 faces. So total how many faces we are having? 6 faces. For each face we are going to count, and for each corner also we are going to calculate. That's why the face centered unit cell consists of how many number of atoms? Total 4 atoms it is going to have. So this is nothing but face centered cubic lattice. So now let us discuss about end face centered cubic lattice. So end face centered cubic lattice, here also what having? 8 corners, 8 into 1 by 8 plus, and coming to here how many faces we are having? 2 opposite faces. So that's why each face consists of 2 into 1 by 2. Then if you get cancel these all, when you add it, 1 plus 1 we are going to get what here? 2 is the answer for the end face centered cubic lattice. And you are going to get doubt in the body centered. Body centered consists of one atom, and why can't we write as 1 into 1 by 2, right? So why we are not writing 1 by 2 into 1? Because it consists of only one atom. Because of the presence of one atom, there is no per atoms, no. So here we are, for one person we can easily give the total amount. If suppose if more persons is there, we can share it. So that's why we have not written here 1 by 2 in the body centered unit cell. Okay, if you are having more than one, then only we are taking per unit cell. So totally end face centered we got it as what here? Here 2 is the answer for end face center. So these are nothing but number of atoms what are present in the 4 unit cell. And we are having radio ratio rule here. So the radio ratio rule is nothing but, see here, the radio ratio rule, when we apply means whenever the coordination number is there, then only we can apply radio ratio rule. Coordination number is nothing but what here? So we have seen, no, number of atoms is going to present. The number of atoms indicates here coordination number. How many number? For example, if you are having 2 number of atoms per unit cell, then the coordination number is only 2. If you are having 6 number of atoms per unit cell, the coordination number will be 6. So in the cubic lattice, how many atoms are present, how many atoms are surrounding to the nearest orbital, that one we call it as what here? Coordination number. Now let us see what is radius ratio rule. The radius ratio rule is nothing but what here? The relation between the radius, coordination number and the arrangement of the molecule. We call it as what here? Radius ratio. So see once again here, the relation between the radius, coordination number and the structural arrangement of the molecule. You will be going to arrange the molecule, no? That molecular arrangement, the radius of this molecule is for example R, and coordination number of these molecules, that one we call it as what? Radius ratio rule. So now let us see the formula. Radius ratio is nothing but radius of cation and radius of anion. So means what here? For example, cation is Na plus, anion is Cl minus. So how many charges we are having? For this 1 by 1. So we are getting only 1 is the answer. Okay, so this is nothing but radius ratio. So if more the radius ratio, then the size of cation will be more and the coordination number it is going to give. So if the radius ratio we are getting more than 5, 6, 7 like that we are getting. So then what happens? The size of the cation is going to increase. Whenever the size of the cation is increasing, automatically we are going to get the coordination number. If the coordination number is more only, we are going to get radius ratio and size of the cation. So next, density. We are having the density formula here, that is Z into Ma by Na into a power 3. So means what here? Ma is nothing but mass number. For example, Na you have taken. Na will be having mass number, no, and Avogadro's number. Avogadro number you will be having, which will be studied in the first years. And Z is number of atoms, how many you are taking. For example, simple unit cell you are having only one atom, right? If you take body centered, you will be having 2 atoms. Face centered, you will be having 4 atoms. So that number of atoms represents Z. Ma is mass of, for example, if you are taking NaCl, so that mass we have to calculate for Ma. And if you are taking Na is nothing but what? Avogadro's number. Avogadro's number we are having constant value. Okay, so A is nothing but what? Side length. So the length of the, for example, this is the cube we are having, this is the corners. So this length we have to calculate. So the length we call it as A. Okay, so this is nothing but radius ratio rule. So we have seen here that this is nothing but radius ratio rule. Okay, so here let us see here structural analysis by radius ratio rule. So basing upon this structure for linear, what is the radius ratio we are going to see here. Okay, so see here, example, if you have been taken HF. HF is a hydrogen fluoride. The shape of HF we are going to have what here? Linear. So 2 atoms only now we are having, one is hydrogen, one is F. Then what is the coordination number will be 2. Okay. So then the radius ratio will be, the value we are going to get in between 0.0 to 0.155. So this is for HF. For example, if you are having boron nitride and boric oxide, so this is having trigonal planar. So if you have been seen, the oxygen molecule is having how many molecules? More than boron, it is having 3. So means what? It is going to get the 3. And you are going to get boron nitride. Okay, so how the coordination number will be 3? See, in between the boron and nitrogen, there is a 3 bonds. So then this is the coordination number you have to take here. Okay, so this is nothing but coordination number. The radius ratio value for this will be 0.155 to 0.225. And next one, let us take example ZnS SiO4. So here for this, the shape will be tetrahedral, and here the coordination number will be how much? 4 is the coordination number, and here the radius ratio will be 0.225 to 0.414. So this is the value we have to get for these molecules when you write these structures. Okay, and if you take NaCl, the coordinate shape will be octahedral, and the coordination number will be 6, and the value is 0.414, 0.732. So NaCl is showing as a one molecule. How we have got 6 coordination number, right? So let us see here the coordination number. So each in a unit cell, in a cube, this is a cube. Okay, so here we are having Na, total at 8 corners. We are going to have Na. So each Na plus is going to surround with 6 Cl minus ions. In a cubic crystal, each Na plus is going to surround with what here? 6 Cl minus ions. In the same way, each Cl minus ions is going to surround with 6 Na plus ions. Okay, so means what here? That's why the coordination number is 6 here. So each Na plus is going to surrounding with 6 Cl minus, and each Cl minus is going to surround with the 6 Na plus ions. So totally how many molecules we are taking? Totally 6 molecules. So that's why what we have written, the coordination number of NaCl is 6. Then the radius ratio what we are going to get here? 0.414 to 0.732. In between this we have to get the value. And let us see next one, calcium chloride. So which is an example shape of the body centered. So calcium chloride, so means what? 8 corners we are having, in between one atom we are going to have. So by that what we can say here, for cesium chloride, so each cesium consists of 8 chlorine atoms, and each chlorine atom consists of 8 cesium atoms. So by this what we can say, the coordination number for this is 8. So then the radius ratio will be how much we are going to get? 0.73 to 1.0. So this is nothing but radius ratio rule. Okay, so by this we can calculate easily radius ratio rule. So this is nothing but unit cell and the radius ratio rule, and how many atoms we are having. In the next class we can discuss about the close packed structure. In close packed structure we are going to discuss 1-dimensional, 2D dimensional and 3D dimensional structure. Thank you.